Good morning, everyone. Good afternoon to those in Asia and further away. And good night for the very courageous and brave one that would be joining us from the US. Obviously, we are thinking of the many people that will watch this as a replay. Thank you very much for being here and discussing something that is pretty technical and built by Marin for a few years now. So thank you very much, Philippe and Marin, for joining me this morning. We are going to wait a couple of minutes for people to have some time to join. It's 9:00 sharp, so let's wait a couple of minutes. In the meantime, don't hesitate to use the poll. You can see on the right side of your screen that you have a quick poll. We wanted to know if the audience, we have quite a numerous audience this morning, and we wanted to know if you had heard and used QCSuper before this webinar. Open source projects unfortunately lack a little bit of communication, so we hope that it's going to bring more awareness and usability on something that is pretty used around the world, but still we can always do better. So
one question for you, Pierre.
Yes.
I think we have half an hour.
Half an hour, yes, 30 minutes.
Yeah. It's quite a dense topic. We can go in many details. So sure. that basically, I hope we'll be able to cover as in depth as we want.
Absolutely. It is very possible that it's going to go a little bit further than 30 minutes, maybe 35 to 40. I mean, the replay will be here for those who have a hard stop in 30 minutes. And obviously, if you want us, for all the viewers here, if you want us to go and deep dive and have some time with Marin, we are talking about extremely technical topics on specific UIs, specific chipsets. If you want to go into details because you are an equipment manufacturer, I know there is some in the audience. If you are regulators who want to understand how chipsets are made, we are definitely here to help, and hopefully we can provide some insights on all of this. What I think we may want to start. I don't know, Philippe, Marin, if you're ready. If you are, then I guess we can kickstart things.
Yes.
Thank you. Well, Philippe, away you go.
Yes, hi. So thank you, definitely. Thank you, Pierre, and thanks to Marin, because this presentation would not exist if Marin would not have developed this tool since a few years now. So what we are going to talk about today is how QCSuper version 2 enables to support the new devices, and specifically new Android releases, which introduced breaking change into these APIs we are using, and also to talk about the 5G support. So first, what is QCSuper? So QCSuper is basically for Qualcomm chipset, a way to capture radio frames that typically are dealt with the baseband processor. And these are typically not seen by the application processor, that is the main processor in your phone that runs your applications, that runs the operating system, etc. So typically, anyone who is working with radio and mobile networks, etc., pretty much wants to go into the depth of what is transiting between the baseband and actually the radio access network, and more precisely with the base station being E node B, but now in 5G with the G node B. So back in 2019, actually, Marin worked quite a lot in order to release QCSuper on GitHub. And that enabled you to capture 2G, 3G, 4G frames. And more importantly, to display them in real time in Wireshark by having a rooted Android phone connected through USB to your laptop. So what's interesting is that it would capture some information about what's going on between your phone and the network. And it's not capturing information, of course, between other phone and the network. So it's not an eavesdropping tool. So it's very different from what you can see in some SDR, software-defined radio implementation, which are tools. There are tools which enable you to actually do some, for example, in 2G, some fake base station and that. So that's really two things, really different. So what basically we are leveraging is really the Qualcomm diagnostic interface. So this interface is a direct way for the baseband chip to expose some information, some diagnostic about radio, about measurements, but also about the raw frames. And that's what interests us. What are the raw frames going at the radio level? And that directly gives that to our application processor, and then to transmit to the laptop which is running Wireshark. So that also means that we restrict here the usage to Qualcomm baseband-based phones or devices. And other things like Samsung or MediaTek baseband are using different kind of diagnostic protocol, which we could possibly add to the support of this tool. But as you know, each generation of baseband chips and operating system requires to be supported. And that's exactly what we are talking about today. So the goal is always to support this evolution, and we're going to see that it's not that easy. So QCSuper easy usage is actually a super easy usage, because you just download the sources from our GitHub/p1sec/QCSuper, and then it's a set of Python source files. You just run QCSuper on your laptop. And here, minus ADB, minus Wireshark Live enable you first to say use the Android debugger to connect through USB to your mobile phone, which has to be connected, and then to try to access this DevDag device on the phone. But this is usually only accessible to root users. So most of the time, you need to root your phone, or sometimes you can actually enable access without rooting your phone. We are going to talk about this, about the device support. And then Wireshark Live means that when you add -- Wireshark Live, it's going to directly pipe the output of the radio from the phone directly to the Wireshark that is going to be run automatically by QCSuper. And it leverages basically PCAP and a GSMTAP encapsulation to pass this diagnostic information from Qualcomm directly to Wireshark. Oops. Right. So graphically, how that works is that you basically have your baseband that is receiving some information both from and to the network through the antenna. It uses a SIM card in order to authenticate, and everything that goes with the network is actually copied over DAG in the diagnostic format. And this is copied toward or read by the application processor running some software, here our own. And then we send these relevant frames to through ADB to the mobile laptop. And then QCSuper runs and produces basically a PCAP file with the GSMTAP encoding, and then Wireshark reads that. And you're going to see that we had to do a lot of hacks, a lot of basically technical things in order to make it work and keep compatibility. So I'm going to let actually Marin talk about his demo.
Yes, so as you are able to see in the screencast displayed on screen, QCSuper can be installed in a quite easy fashion. You can use a PIP package manager that's bundled with Python programming language. and then it is on Linux, it is directly usable as a standard command. So in order to use QCSuper, you will first have to plug to plug your phone in USB with 8 dB Android debugging mode enabled, and QCSuper will tell you with an error message if it's not plugged in, and then if ADB is enabled and the phone is root and has a compatible Qualcomm chipset, you will directly be able to see RRC, donc RRC radio resource controller frame, and other paging and broadcast radio frame emit and received by your phone in Wireshark. You also need to Wireshark and Python installed on your machine to run the tool. So as you can see, you can have you have various interesting radio identifiers present in the capture frames, like your temporary MD number, or you have a paging frame, RRC uncheck frame. It is RRC broadcast, but QCSuper capture 2G, 3G, 4G, 5G frames. You have, for example, a frame related to the uncheck of negotiating security protocol. There is a security mode command NAS frame that is exchanged with the core network of your operator. And you have a frame related to the RRC and check in general. So the process when your phone connects to the core network of your mobile operator. Everything of this is displayed in Wireshark with one command, testing the tool on a compatible setup. Rotate phone. So in the following slide, we will provide some news on the recent evolutions of our QCSuper. So the ecosystem of mobile phone devices and broadband chipset is evolving constantly, and so we had to make some evolutions into QCSuper in order to ensure compatibility with recent Android devices. So previously, QCSuper and Qualcomm based device was communicating with a Unix device present on almost on almost all Qualcomm based on Android phone that was called /dev/diag and was accessible by default by root users. But in certain recent on Android phone and kernels, on Android, there are specific flavors of kernels depending on base chipset. So for the Qualcomm MSM chipset Android open source kernels based on mostly on Linux kernel 5.14 and above, but not exactly this. You may not have the /dev/diag device available on the phone because there was a kernel option that was enabling it. That was set by default in the kernel setup, so we will have to use other way to communicate with the diag interface on the phone. So mostly, so this started to disappear from Android 10 to 12 kernels, and we almost have a node/dev/dig device on Android 14 and above, due to the best kernels. So in order to overcome this issue and to follow the technical evolution in the Android core, we will no more to transfer a binary connecting to DevDeg over ADB and run it and to transfer the frame over TCP. Instead, we will have to directly leverage connecting to a DAG pseudo-server interface over USB that is parallel to the ADB interface. So now with the recent Android phones with Android 13 or above, we mostly have QCSuper function like other predicting tools like the desktop version of QXDM or KSite. So we will try to connect to a DAG interface over USB that is parallel to ADB. So first for this, we have to mode switch the device in order to have the DAG device exposed in parallel to ADB, because by default it is mostly almost never the case. So we will have to do a mode switch in order to have a DAG exposed in parallel to ADB. So this is done using setprop and the device, and when run this way through the ADB shell, this almost always requires root rights. So QCSuper will try now with the -ADB flag to automatically mode switch the phones if DevTag is not present, to have this DAG interface over USB exposed. But now this also in certain cases allows to use QCSuper on phones with which have not been root. Because often on Android phones you have a specific vendor menu that you can make appear using, for example, a special combination of keys on the keypad of your phone application that will have an hidden menu appear that will allow you to enable the DAG interface over USB with those routings. So now you can also use QCSuper on certain phone with rules. You can enable DAG separately using special very specific ways, like magic keypad combination. And also on certain vendors like Xiaomi, you can vendor signed APK files that can also enable the DAG interface without routing that exists. It depends on your phone model. So there are some like that also but in the README of QCSuper and GitHub that give a more specific and interesting context about this. So no QCSuper will rely on this instead of trying to hit devdiag when devdiag is not available on machine devices.
Yeah, so there's now, thank you very much. Now, typically what we do is that actually QCSuper is automatically trying to switch the USB communication mode to this having the DAG interface in parallel. So the big change is that we are not anymore accessing DevDAG within the phone. We are actually activating a parallel stream on the USB channel, on the USB wire, actually going from your phone to your computer, so that this stream carries directly the information. So we need now to receive it by QCSuper, right? So you can also do that manually by trying to define that you have this DAG over USB. We try to leave a lot of freedom to the user in order for the user to be able to actually do what he wants, what she wants. So, oops, sorry, did I click on the? Yeah. So now what that we preserved actually is a functioning of QCSuper with recent Android. Of course, this is part of the maintenance, and we'll talk about why maybe that was done. We also wanted to be able to have 5G compatibility because these new devices have most of the time 5G support. So what we have is typically we've been using since the beginning the GSMTAP encoding that the developers at Osmocom project created so that Wireshark can decode what's coming from 2G, 3G, 4G, and now 5G phones. But actually, the sub-protocol field of GSMTAP was not updated so that we could have direct decoding by Wireshark of 5G frames. Wireshark itself supports perfectly the decoding of such, but we need to have this subfield that says, oh yeah, it's basically 5G, RRC, etc., within the next layer. And that's what is missing. And GSMTAP actually has, there's a plan by the author of another tool called SCAT to update GSMTAP to v3 so that it would enable Wireshark to directly dynamically detect that it's 5G radio frames, but it's not there yet. So in the meantime, what we've done is that we upgraded basically our usage of Wireshark so that we could patch this in when we run dash Wireshark Live with QCSuper. And the way we do it is we installed a Lua script within the startup folder of Wireshark, so that this Lua script adds a dissector so that there's decoding, good decoding, even though we're using a GSMTAP format, which does not support that automatically. And basically, Lua is a very small and embeddable shell scripting, just as Python, but much more lightweight. And that's the default scripting engine used by Wireshark in order to extend it without developing directly in C. We don't need to be so fast that we needed it to do it in C. So actually, Lua was perfectly reasonable for that. Now, what it enabled us is that it enabled us to actually get the radio frames. Here you see the output from a Snapdragon 855 with a Qualcomm X50 5G modem. And on a Xiaomi Mi 3 5G phone. Then here you can see that we see RC. And we are really actively looking for feedbacks, because this is really what is interesting to see what works, what doesn't, etc. So typically what we will see here is we're going to see some information such as here some security configuration using NEA2, which is a secure and default encryption algorithm for 5G ciphering. So, which is good because we can verify security properties, and that's the case. That's really typically what we at P1 perform, is that we use this tool. Now, not everything is very beautiful in this area, because there are known limitations that were actually introduced by the support of Qualcomm into this tool. And the known limitation is that now we don't see NAS anymore on the DIG interface. So that means that the non-access stratum signaling, which is very interesting for many things, is actually not anymore in the DIG output. And we're really looking here for collaborations in order to find the root cause of it. So some people said that actually Qualcomm was quite volunteer there. They wanted to remove this because they are selling these diagnostic tools on their own. And QCSuper is a free version, of course, very limited compared to their tool, but it's a free version. And some people were saying, well, that was an intent. They don't like that people, they may not like that people are using free tools to get access to this quite valuable information. So that's a hearsay. I'm very much interested by feedback from everyone here, but our goal is really to add back this NAS support in 5G, basically in 5G frames that we see with QCSuper. Typically, we also want to go toward more compatibility. There's some polls that have been pushed by Pierre, and thank you for that, about upcoming workshops that we may try to perform more in a more interactive, less webinar kind of way. So if you're interested, just answer to the webinar, or actively contact us, either through the GitHub discussion or GitHub issues, or actually by mailing us. Now we have a dedicated email for that. In terms of if you want to participate into some project, actually we even may have some funding for some of these, so definitely don't hesitate. We are really looking for contributors and expanding not only QCSuper functionalities, but also expanding our knowledge of which devices work, which interesting things that were found with QCSuper, and to really raise the community here. Now, the next part is really about what we can look for. So as you understood, definitely a community is super important. So if you're willing to participate or wanting to get into there, but you're unsure, that's where we could go into this workshop. Definitely connect to our GitHub and have a look there on the tool, on the issues, on the discussion, on the support, etc. And let's go into the Q&A. I'm not sure if we were right on time, Pierre. What do you think?
We are indeed right on time, 9:28.
I was a bit spooked out. I was unsure we were going to be able to to finish in time. There's so much to say. Actually, in QCSuper, there are so many things that Marin has put in the tool. You can access the file system of the baseband, the so-called EFS. You can do plenty of stuff. So definitely, it's a tool that is very interesting and so much to discuss about. But as I said, let's see if there's interest for a more advanced workshop. Do we have questions?
We don't have any questions. I see a few people who have left already, so I guess they had the answers they were looking for. I understand that most of you heard about QCSuper but never used it, so take the opportunity to use it. As Philippe was saying, we have loads of ways to communicate and discuss with you, and we are really eager to know more about your usage. So let us know. contact us if you have any questions. If those questions cannot be addressed publicly, let us know in the different mediums that are at your disposal. But as usual, thank you very much for your time, for your attention, and looking forward for the next one.
And thank you, Marin, for this precious tool.
We do have Henrik just share with us just before we go. Thank you, Frank, trying QC. This is great. And Philippe, I will leave you to handle Henrik's question.
Yeah. So very interesting. The question from Henrik is there a plan to support features like band locking via DAG over USB? And yes, definitely, that's typically the goal. So especially in 5G, this is important because, as you know, there's basically the MM wave band, basically high microwave within the spectrum, which become available on some models. So it's quite interesting to be able to say, okay, I just want to have a connection through these bands. And here it's typically the kind of things that we try to add within QCSuper. But here, having basically not only information on how to do it, but also a community to be able to test it, that's super important for us. So Marin, do you want to add on this, on the specifics of basically the protocol format and some basically documentation or reverse engineering in order to activate this active command, because we have to send things so that there's then locking that basically started.
Can you please precise
so
what you are thinking about when
so it's basically restricting the frequency of usage of the baseband modem to certain frequency only. So it's also called band locking.
I don't know if we will be able to implement this easily in a privileged fashion. I think we should look again at the specifically available comments in the DAG protocol framing that would allow to do this, but I think that switching the radio access technology may be more easy to do in other Qualcomm specific interfaces, such as QME protocol, that is another protocol related to DAG related to Qualcomm basebands, but is parallel to DAG and allow to do more things like I think changing the word related to the link, and also other channel directly the UI of your Android phone and or AT commands may be more suitable to do this. I don't remember exactly. I should check. So I see that we have other questions in the.
Yep. So I'm going to thanks for your answer, Marin, and I'm going to read the next one from Ariane. So if the Qualcomm baseband is embedded in the module from e.g. Quectel, for example, Quectel, are there any AT commands that allow to enable diagnostics? So I'll start with basically an answer. So as I recall, on many systems or phones, the enabling of the DAG interface is done by dialing special strings such as ****717717 ****, etc. So this kind of very old and traditional way of to do it. So I wonder if some ATDT with this AT command to dial it would trigger this. Now, Marin, do you have some more information about this?
There are often IT commands that allow to enable a diag interface over USB in USB modems that are present, but very often these commands are vendor specific, and you usually need to search over search engine often on Linux-related question answer forums or wikis commands to enable other interface over USB on your AT communicating modem when they are not present. So we have our Coactel EC 25 modem for your personal testing uses, whereas the diag command, the diag interface is directly present and multiplexed over the USB channel, which is more manipulation to do, but we don't have exactly specific procedures to documented to enable it when it is not, but often there are proprietary IT command to enable the diag interface when it is not present and displayed in the system to try to enable it, and you can usually have this vendor specific info through searching for your device on the search engines, but often the diag interface is present over USB, but it may not be recognized natively by your operating system directly with manipulation like an actual pseudo-serial character device. So when it is not, you often have you may have to use a command like ls USB space -v on Linux to see all the interface. So often the diag interface is at least something like 255 in many fields, class, subclass, etc. And often when there is not /dev/tti USB as something present on your system, you can also make this appear manually on Linux using a command like sudo modprobe USB serial and manually have a character device appear on your Linux desktop system with modprobe command. So all this is documented on the new QCSuper README on GitHub.
Yeah,
and
so
this,
I think, yeah, definitely there's ways. I was also, sorry to interrupt, Marin, I was also reading into some specification sheets here from Terra Wireless. We were using apparently some Qualcomm. And definitely there's some AT command where you give a bit mask that tells the USB compositions that you want. And telling that you want to access the modem, but diag at the same time. And then your operating system then has a task to be able to map that into devices. So definitely that's what we can look at. Having access to the devices is great. Also, what we know is that some of the people using QCSuper are also using QXDM tool from Qualcomm. So that's also very useful in order to see how they do it, how we can do it. The next question is, do you plan to extend this tool to other chipsets? So actually, yes, we've done something a bit like this. So for example, if you go in a GitHub, you can see in P1.6 there's some project called LTE Monitor C2XX, which enable to activate monitor mode for some Samsung baseband devices. Now, really, one thing that is important to know is that Qualcomm represent more than 80% of the baseband market. So that means that most of the time, you don't actually, you can pretty much find easily some Android phones with the Qualcomm chipset, which is the most common. And so that's why we focused on this one so far. And then there's a question. The next question is, QCSuper can work with test board like this. So with a Sysmo QMod, basically evaluation board. So here, I think this one, so typically QCSuper is really dedicated to Android device, and I don't think this one is an Android device, does it? So I would say here it's directly the modem, isn't it? So I would tend to say no. What do you think, Maran? And Sysmocom stuff is great, but I think it's...
Yeah, it is not whether this device may work with QCSuper, as we did not have any feedback related to this kind of advanced usage device, but as this is delivered by Sysmocom, I think that you may want possibly to directly ask Sysmocom about this and parts other than IT are provided through the board. There does not seem to have a very specific and detailed information about the protocol routing in the data sheet present in the page that you link through. So I think if you think about doing this but don't know whether the DX framing or QMA framing will be forwarded actually in addition to SIM or whereas when June, I think you may want to ask directly the Sysmocom vendor about the capability in protocol forwarding enabled by this device.
Mm-hmm. And I typically that's something we could talk with Harald from Sysmocom and with the guys there because they do pretty open stuff, so definitely yes. And there's a question about the best phone to test for 5G capture is Xiaomi 11, right? So yeah, it's quite good because you don't need to root it in order to activate the tag. Now, the best phone is actually the phone that is available to you, and that's the most important thing. Now, we are trying to put into the wiki of QCSuper on GitHub information about device support. So we'll continue doing that in order to try to have easy way for people to get access to that. And what we kind of think is that the support for decoding the 5G NAS will probably be differing from one model to the other, because there's really differences between one model and the other. So right now, we know that it works with Xiaomi, and we mentioned, and with some other phones, but we can't say that one is best than really than all the others. When we'll have the NAS support, we'll say, okay, yeah, try this one, because this one is really, really important. Any other question? That's cool. There's quite a few questions that came in.
We've had the questions right at the, we almost clicked end, but the question came. Thank you very much to everyone and for all the great questions. They're going to be very valuable for the replay users. So again, thank you. Let's speak soon, and see you next time. Goodbye, everyone.
Thank you, everyone. Once again,
Bye-bye.
thank you, Marin.
Thank you, Marin. Thank you, Philippe.
Thank you.
And yes, thank you, Pierre.